Okay, this is 8.6 in your textbook. We're looking at volume and surface area of a sphere. Almost done here. We got one more lesson that we're going to do. We're going to skip 8.7, go right to 8.8, and that's the end. Okay, so second last lesson. We're looking at volume and surface areas of spheres. So one of the things we figure we discover in the investigate is we develop these two formulas: the surface area of the sphere, and the surface area or the volume of a sphere. Okay, so we're going to need and use those two formulas. Again, on the EQAO test, you're going to have a formula sheet, so you need to just be familiar with those two formulas. The question says that Dylan must buy 100 spherical balloons for 8 cents each. The helium that he needs to buy to fill the balloons is 2.4 cents, or is $0.024 per liter. Okay, each balloon inflates to a surface area of 900. How much will it cost to buy and inflate them? So because the one piece of information that we're given that we know we can use with our formulas is this surface area. Okay, so right away you should think of the formula for surface area, which is here. So if you get a question like this on the EQAO and you're given a value of surface area, you want to that should trigger you right away to look for this formula. And the reason why we need to go to this formula is because we're not actually given the radius of the balloon. We're told that they're spherical, so they're not like, elliptical like your typical balloons. They're not like that, okay? It says that they're spherical balloons, so you have to assume then that they're exactly, perfect circles, okay? That helps us with our calculations, because if it was a shape like this, we don't have a perfect formula to calculate that. Okay, at least not yet anyways. So we have our surface area formula here. We're going to plug in 900 for the value of surface area, which I've done here. I leave all the other variables as is, because we don't know them. The only unknown of those being r. Right? We know what pi is, so we now need to solve for r, and we can figure out the radius of our balloons. So I move these two to the other side by dividing both sides by 4 pi. You see how necessary algebra is now? It's just assumed that you guys know how to do this. Okay, so you need to be very familiar with this. If this part here is confusing, you need to do a pretty thorough review back into the earlier chapters. Yeah.
Can you just put pi in the calculator and
yes.
It'll do it?
Yes.
You don't have to put 3.1?
No. Just use pi. Okay, it's also more accurate to do it that way. Janoshi.
Sir, when you move 4 pi to the other side, wouldn't it be a negative then?
No, because you're not adding or subtracting. It's not like 1 plus, it's not moving over. It's actually multiplied by r, so you need to divide both sides by 4 pi. Okay? So if you're not familiar with that, please review it, because you got to be comfortable. You can see how many marks you're going to lose if you can't get past this step. Yeah, Matthew.
If we, on a test or like the exam here, if we use 3.14 instead of pi, and we're like a bit off, would we lose points?
It depends on who's marking it. I would use pi on your calculator. Okay. Your accuracy too is going to depend on how many further calculations you need to make, right? If you keep using 3.14 and it's one of your early calculations, like your first one here, then it'll just increase your error as you continue to use that value. Okay, through further calculations. All right, so then we solve for r. Any questions about how I go from here to here? Nobody? Okay, so I figure out my r, my radius is 8.47. So that tells me this distance, right? If here's my sphere, I have 8.47 centimeter radius on my balloon. All right, next thing I want to know is, I need to know how much it will cost to buy and inflate them. So I know they cost 8 cents each, but I also know that the helium costs this much per liter. This liter calculation here should tip you guys off that it's a volume. It's a volume variable, right? We need to know how much volume, in liters, how much gas this balloon takes up, right? And the only reason that you go to this formula, the only kind of indication, the only hint that you have is this unit, liter. Okay? Or if you see centimeters cubed. You know if it's cubed, we're talking about volume. You know if it's liters or milliliters, we're talking about volume. All right? So there's your big tip-off to use this formula. Okay? Not sure how else to teach you guys other than looking to give you guys clues on how to go from here to here. 'Cause some of you might stop there and then not know what to do. Okay? But there's the tip off. So we need to figure out how much volume is in each one of these balloons. So we use our formula for volume of a sphere, which is 4/3 pi r cubed. Now, and we substitute our value of r in, which we calculated in the previous formula, which is 8.47. So we end up with a volume of 2,544 milliliters. Converting that to liters, 2.544. Everybody familiar how to convert between units? Yes? 1,000 milliliters in a liter. Decimal place moves three spots. 1, 2, 3. Okay? That's important because the price that we're given is in liters. So we need to convert it from milliliters to liters. If you multiply milliliters by this number, you're going to be off a factor of 1,000. Okay, so very important that we know how to convert those two. The cost of helium is given at 2.4 cents. We take that value, multiply it by the number of liters, and we have the total cost of our helium. Not too expensive, about 6 cents. Once we have our cost of helium, we can add that to the cost of the balloon and multiply it by the number of balloons that we need to fill and buy. So 100 times 8 cents per balloon plus about 6 cents to fill each balloon. So our total cost becomes $14.10. Any questions?
What's
Yeah.
the 100 for?
There's 100 balloons that he's got to
Oh,
fill.
okay.
Okay? Alright, moving on. This one is a little trickier. This person wants to create a bowl in a shop class. Alright? So, the way they did it, and I don't know if this is the best way to create a bowl, but hey, this is the way this person decided to do it. They decided to carve out, so you gotta kind of imagine that this half sphere is on, the midpoint of the sphere is right on the top surface of this cube, and then this part all here is dug out, okay? Kind of like an ice cream scooper out of the very top. Okay, so they've dug it out. So if you're looking at a side view of that cube, it looks something like that. Okay? So they're asking, they want to varnish this cube. So we know what varnish is. It's like painting it, right? We're coating it. So they need to know how much surface area that this cube contains. So in order to do that, we need to know the surface area of this side, the back side, both sides left and right, and the bottom as well as the top. Okay? The top is tricky though because we have this half sphere cut out of it. Okay? So you could get the surface area of this area just by finding the surface area of the cube and then minusing the circle, but you also need to include the surface area on the inside down here. Okay, that surface area of the curvature of that half sphere. You guys understand that? Trying to make the question as clear as I can before you start. Because really that's the challenge in some of these problems, just understanding what to do. Because the process is relatively easy because you're given these formulas. So they're kind of like plug and play in a sense, where you just get a value, you plug it in the formula, you do a bit of algebra, and you come out with an answer. But it's very important, and oftentimes the most difficult part is trying to understand the problem. Okay, so really take your time when you actually are reading these. You got a question?
Yeah, no, you guys.
Okay, so it says, what is the surface area of the bowl? So we're finding out the surface area of all the sides, including the inside surface area of that sphere. So we're saying our surface area of our bowl is equal to the surface area of our half sphere plus the surface area of 6 squares. 1, 2, 3, 4, 5, 6. That's the top one we're including now, minus the surface area of one circle. That's because if we include the top square, we have to take away that part that's no longer part of the square. You guys understand that? Okay, good. So the surface area of our sphere then, we know from the formula is 4 pi r squared. That's surface area. So again, back to this formula right here, right? Remember, when we're dealing with surface area, it should always be a square term. When we're dealing with volume, it always should be a cube term. The surface area of the half sphere then is 1/2 of this. Okay? Once we know that, we just sub in the value of our radius, which was given as 8. We do the calculations. We can put this all in our calculator at one time, just as it is. We figure out that it's 402. So that's the surface area of our half sphere. Now we're figuring out the surface area of the 6 square sides. So this is also given. These are given as 20. Okay, that's easy enough. It's just going to be 20 squared. So the surface area of 6 squares minus the surface area of the circle. So we have 6 times the side length squared, so 6 times 20 squared, minus the surface area of that on top circle. So if here's the top view, we're taking out this surface area now. And again, so we just used the formula for surface area of the circle, which is pi r squared. So that's right here. So now we get our total surface area of 2199. That's for all of our squares and the top piece. And then we just add those two surface areas up and get our total surface area of our bowl. I don't know if I'd even call it a bowl. I'd call it like a square with half a sphere out of the top. But anyways, she calls it a bowl. So there's our surface area. Now to figure out our volume is going to be the volume of the entire cube minus half of that sphere on top. That makes sense? Because you've taken out that volume, right? We've cut it out. So we use the volume of our sphere. We cut it in half. So 1/2. There's our volume formula. Figure out that that's the value we need to subtract from the cube volume, which is just now 20 cubed. 20 length times width times height. 20 times 20 times 20, which is 8,000. So our volume of our wood then is 8,000 minus the volume of that half sphere. Okay.
20.
20 is just one of the side lengths. 20 times 20 times 20.
And that's the kind of volume of the whole thing.
Yes.
And then you subtract
Okay.
that.
That's it.